Everybody, here are the notes for homework number 20, the last homework assignment, more trig equations. This first one's kind of an anomaly, and then the rest of them after this will kind of have the same sort of format. So we'll do this first one. I got sine of x plus 2 cosecant of x minus 3 equal to 0. This looks problematic. I would probably start by rewriting it as sine of x plus 2 times 1 over sine of x minus 3 equal to 0. And then I would multiply everything by sine. Multiply everything by sine. I'm going to get sine times sine, so sine squared plus 2 times 1 over sine times sine is just 2 minus 3 times sine of x equal to 0 times sine of x is 0. And then I would rewrite this in more typical format, meaning I would write it with the highest power sign first, then the next sign, then the 2. So I'd write it as sine squared x minus 3 times sine of x plus 2 equal to 0. You don't have to, but I like to do the u substitution. So I would say, great, u equals sine of x, u squared equals sine squared of x. Rewrite this as u squared minus 3u plus 2 equals 0. Hopefully it factors. If it doesn't, use the quadratic. It does factor as u minus 2 times u minus 1 equals 0. So we either get u equal to 2, which leads us to sine of x equal to 2, but that has no solution because sine of x is always between -1 and 1. I should again point out before we get further, all of our answers in this section, and whenever we're solving trig equations, all of our answers are where x is bigger than or equal to 0 and less than 2 pi, or whatever the angle is. Sometimes it's x, sometimes it's theta. So this is always our requirement. Or we get u equal to 1, which leads to sine of x equal to 1. And then we can, I have my little handout here. We can either say sine of x is equal to 1 at the top of the unit circle here, or we can say sine of x is equal to 1 by looking at the graph and be like, oh yeah, sine of pi over 2 is equal to 1 right there. Either way, the angle is pi over 2. So that leads to one solution, x equal to pi over 2. Sorry, just give me a text message here. Look here. Okay. So continuing on, the rest of these will have kind of another different aspect to them, meaning that, well, specifically the next one, cosine of 2x equal to -1/2. So up until this point, we've really been mostly solving cosine of x, sine of x, tangent of x equal to a number that's recognizable. For cosine of 2x, you really don't want to use a trig item. You could. I feel like it would get pretty messy though. Like cosine of 2x would be cosine squared x. So here's the way we don't want to do this really. Cosine squared x minus sine squared x equal to -1/2. And then you could use the trig item for either one of these and say, well, it's going to be like 1 minus sine squared x minus sine squared x equal to -1/2. That doesn't seem great. You have let's add 1/2 here. So say 3/2 and minus 2 sine squared x equals 0. Add that over there. So 3/2 equals 2 sine squared x. So then 3/4 equals sine squared x. So then the square root of 3 over 2 is equal to sine of x. And then we know that sine of x is equal to √3 over 2. Oh, sorry, I forgot a plus or minus there. Important. And then we know that the reference angle for sine being equal to √3 over 2 is, I believe, pi over 3. Let's take a check. Let's take a look. And pi over 3. Oh, I should just grab my little triangle. I'll just draw it again. Pi over 6. That's a 1. That's a 2. That's a √3. That's the right angle. So yeah, sine of pi over 3 is √3 over 2. So we know that our angle is pi over 3. And then we want to answer in each of the 4 quadrants. So we want in quadrant 1, pi over 3. In quadrant 2, we want 2 pi over 3. So that's the reference angle. Just a minute. reference angle is pi over 3. In quadrant 3, we want 4 pi over 3 because the angle is pi plus pi over 3. Right? That's your reference angle, pi over 3. So it's pi plus pi over 3. And finally, in quadrant 4, 5 pi over 3. Because the angle is 2 pi minus pi over 3, which is 5 pi. The answers here would be pi over 3, 2 pi over 3, 3 pi over, 4 pi over 3, and 5 pi over 3. But this isn't the way I want you to solve it. Although you could solve it this way, but you couldn't solve it this way if it was like cosine of 40x. So here's a totally different way to solve a problem like this and to solve the remaining problems after this. So what we're going to do, even though we know the answers are pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3, all angles that have the same reference angle of pi over 3, notice they all have the same denominator. But we're going to do this instead. You say, well, I'm going to think about trying to solve just cosine of my angle. Let's call it theta for a second, equal to -1/2. I know if I'm trying to solve cosine equal to -1/2, my answers should be in quadrants 2 and 3, right? Because all students take calculus. I don't want anything where cosine is positive, so not there or there. And for cosine to be -1/2, the angle has to be, well, again, it's going to be pi over 3, right? Because cosine of pi over 3 is 1 over 2. So I should say the reference angle has to be pi over 3. So I'm thinking this angle here, where the reference angle is which is an angle of 2 pi over 3. And this angle here. Let's try it again. This reference angle is pi over 3, and the actual angle is 4 pi over 3. Here's the deal. We don't just want our angle to be 2 pi over 3. Well, I mean, we do theta, but our angle is 2x. What we're going to actually say is, great, we're going to get 2x equal to 2 pi over 3. And 2x equal to 4 pi over 3. So that we actually get x equal to pi over 3 and x equal to 2 pi over 3. Dividing both sides by 2. The problem is that's not enough answers. So let's think a little bit more about this. If I was to graph cosine of 2x, well, for the graph of cosine of 2x, the period is 2 pi divided by 2, which is just pi. So what happens here is from 0 to pi, you get 1 full period. Cosine starts up here at 1, and, it has the usual shape. There. It looks like that. And then it repeats itself. So one thing we know about the 2 there is from 0 to 2 pi, you're going to get 2 full periods. Well, great. If I'm trying to see where cosine is equal to -1/2, there's -1/2. It looks like there's 1, 2, 3, 4 different answers. Here's what I have to do. I have to take my first answer, which is occurring at pi over 3, and I have to add on a whole period, which is pi, to get another answer over there. Same deal here. This answer here, which is 2 pi over 3, I'm also going to add on a whole period to get that answer over there. And in this case, 1 period is pi. So I'm actually going to take my 2 original answers, I got from saying, my angle that I want to take cosine of is 2 pi over 3, but then that means x has to be 2 pi over 3 divided by 2, which is pi over 3. I'm going to take my x equal to pi over 3, and also I'm going to say pi over 3 plus pi, which is 4 pi over 3. Similarly, I'm going to take this 2 pi over 3 answer, and also I'm going to say 2 pi over 3 plus another pi, which is 5 pi over 3. Look, oh, sorry. Same answers. Pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. So the idea here is that after we find the kind of original answers, like the first answers, the first couple answers usually, we then are going to add on whatever the period is for our expression. In this case, cosine 2x, the period was pi, until to get the rest of the answers. Now, we could keep going, but the problem is we only should get 4 answers, because if we go any further, we're going to be beyond 2 pi. So like if you continue this on here, right, the next answer down here would be past 2 pi. If you kept adding on, like if you added on another pi here, you would get 7 pi over 3, which is too big. So it's good to think about how many answers there are going to be. Typically, this number here, that coefficient of x, is going to be the multiplication factor of the number of answers. So usually, cosine of theta equal to -1/2 would have 2 answers. One in quadrant 2, one in quadrant 3. So that 2x there, that 2 is going to double the number of answers. Since we need 2 answers, we got 4. Let's look at another example. If I can read the paper. Yes. Sine of 3x equal to √2 over 2. So let's think about the number of answers. So first of all, we know that our answers should be, well, at least to find the angle, our answer should be in quadrant 1 and quadrant 2. We know that pi over 4 is the angle, the reference angle. So we know that sine in quadrant 1, pi over 4, right? That's the, if you look at our triangle here, right? Sine of pi over 4 is 1 over √2, or √2 over 2. That's our quadrant 1 answer. So we'll look at sine of pi over 4 is equal to √2 over 2. And in quadrant 2, it's the same. That's a reference angle of pi over 4. And then our actual angle is pi minus pi over 4, which is 3 pi over 4. After our quadrant 2. So we also know that sine, we'll right over here actually. Sine of 3 pi over 4 is also equal to 3. Here's the deal, right? We're going to actually have 3 times as many answers. We're going to have 6 answers. And there's a couple ways to see this. You can either just say, well, I want 3x to equal the pi over 4, right? This here has to equal the angle that we're taking sine of to get the value that's intended. So we're going to say is, hey, we need 3x to equal pi over 4. If we divide both sides by 3 or multiply both sides by 1/3, x is going to equal 1/3 times pi over 4, which is pi over 12. Similarly, if I'm going to leave myself some room there to fill in more there, if 3x is equal to 3 pi over 4, then we're going to get x equal to 1/3 times 3 pi over 4, which is going to be 3 pi over 12, which reduces to pi over 4. And then to get the rest of the answers, we're going to take the period of this function. Oh, the period of y equals sine of 3x is 2 pi divided by 3. And we're going to add that on to get another answer. So this is one answer. Another answer is going to be pi over 12 plus 2 pi over 3. We should use the common denominator. So I'm going to multiply 2 pi over 3 by 4 over 4 and get pi over 12 plus 8 pi over 12, which is 9 pi over 12, which reduces to 3 pi over 4. We can do it again. We add on another 2 pi over 3, and let's actually add it on to 9 pi over 12. So another answer is going to be 9 pi over 12 plus another 8 pi over 12, right? I'm just adding on another 2 pi over 3. I'm going to get 17 pi over 12. Same thing down here. I'm going to take my answer of x being pi over 4, and I'm then going to say, okay, well, that's one answer. But then also I'm going to get pi over 4 plus 2 pi over 3, which common denominator, that's going to be 3 pi over 12 plus 8 pi over 12, which is 11 pi over 12. And then take that answer and add on a period again. 11 pi over 12 plus another 8 pi over 12, which is 19 pi over 12. If you tried to add another period on to either one of these, it's like if you added on another period of 8 pi over 12, you get 25 pi over 12, which is bigger than 24 pi over 12, which is 2 pi. Same deal here. If you added on 8 pi over 12, you would get 27 pi over 12, which is also too big. So if you think about the number of answers you're going to get, in this case, originally 2 and then 2 times 3 is 6, you should get that many answers. If you go further, it's too big. Another way to see this is to see that, well, sine of 3x, if we were to graph it, there would exactly be 3 full periods from 0 to 2 pi. So break this up into thirds. So in this first period from 0 to 2 pi over 3, we're going to get 1 full sine period. So it looks kind of like this. And then in the next, so that's 2 pi over 3 right there. And then from 2 pi over 3 to 4 pi over 3, we get another full period. And then from 4 pi over 3 to 6 pi over 3, which is 2 pi, we get another full period. And if we're trying to see where sine is equal to positive root 2 over 2, which is about 0.7, well, there's 1. There's about root 2 over 2. Let me zoom in a bit. You can see, oh yeah, look, there's 1, 2, 3, 4, 5, 6 answers. Pi over 12, 3 pi over 12. So, I mean, I'm not reducing right. So there's the first one's going to be pi. I don't need to write the beginning really, but pi over 12. That's pi over 4 or 3 pi over 12. This next one over here is going to be the 3 pi over 4, which is 9 pi over 12. The next one's going to be the 11 pi over 12. This one over here is going to be the 17 pi over 12. And this last one's going to be the 19 pi over 12. Again, there's no reason for you to write these down. I just want you to see that, oh yeah, we really are getting as many answers as we said because we're just finding all the places this sine of 3x function, which is just 3 periods of sine from 0 to 2 pi, all the places between 0 and 2 pi where sine of 3x is equal to root 2 over 2. And there's 1, 2, 3, 4, 5, 6 spots. Okay, so I'm going to stop with the graphing and just kind of show you how we do this the way I've been doing it with kind of as quickly as possible. So let's look at solving tangent of 4x equal to root 3. So tangent of 4x equal, so I know the angle I'm looking for. I'm just thinking, okay, I'm thinking over here. I like the little thought bubble. I'm thinking, great, tangent of theta equals root 3. And I know that for that value, the angle is either pi over 6 or pi over 3. I'm thinking of, okay, here's my, let's see, tangent of pi over 6 is 1 over root 3. No, that's not right. Tangent of pi over 3 is root 3 over 1. So anyway, my reference angle is pi over 3. I know the quadrants I want. Well, I want tangent to be positive. I want the first quadrant or the third quadrant. So in quadrant 1, the angle is just whatever your reference angle is. So my angle would have been pi over 3. In quadrant 3, well, I'm going to draw it, right? Pi over 3 right there. Pi over 3 right there. So the actual angle is going to be, let's be using blue. The actual angle should be pi plus pi over 3. So cool. Okay. But that's not what x is. That's what theta is. So if I was just solving tangent of theta equal to root 3, I would normally get 2 answers. But since I'm solving tangent of 4x equal to root 3, I should get 4 times 2. I should be expecting 8 different answers. Okay. Tangent's always a little weird. You can kind of do it differently, but I'm just going to do the usual way. So for tangent, just like the previous ones, take your original answer and then solve for x. So I'm going to get 4x equal to pi over 3, which is going to be x equal to 1/4 times pi over 3, which is pi over 12. Similarly, 4x equal to 4 pi over 3 is going to lead to x equal to 1/4 times 4 pi over 3, which is going to be pi over 3, but I'm going to leave it as 4 pi over 12 because it's usually in our interest to not simplify it until the end because just you usually have to do the common denominator. Great. So then I'm going to take each of these and I'm going to start adding on periods. Now, remember the period of tangent. So the period of tangent, let me write that here. The period of tangent of x is pi, not 2 pi. So the period of tangent of 4x is going to be pi divided by 4. So that's what we're going to add on to get the rest of our answers. So we're going to take our first answer of pi over 12. And I'm going to start labeling these. Like, so my x1 is pi over 12. And I'm going to find the rest of them by just adding on pi over 4. So x2 is, well, let's see, pi over 4 times 3 over 3 is 3 pi over 12. Let's just be smart and add on 3 pi over 12. So it's going to be pi over 12 plus 3 pi over 12, which is 4 pi over 12. And then x3 is going to be the previous one, 4 pi over 12, plus another 3 pi over 12, which is 7 pi over 12. And the fourth one, x4, is going to be 7 pi over 12 plus another 3 pi over 12, which is 10 pi over 12. And as far as writing the answers in your homework assignment goes, you should reduce these. So this one we should really write as pi over 3. This one we should really write as 5 pi 6. And then we have 4 more answers. So our other answer, let's say that x5 is 4 pi over 12. Then the next one's going to be, so I don't think you need to show all this work I'm showing. Like, I know you know that 4 plus 3 is 7. So 4 pi over 12 plus 3 pi over 12, we could just jump to the conclusion and say that's 7 pi over 12. And then the next one's going to be 7 pi over 12 plus 3 pi over 12. I feel like I've made an error somewhere. This happens sometimes with tangent. Right, because the answers were exactly pi away from each other. Sometimes with tangent, weird things happen. So yeah, I'll point out that this answer was already gotten to right there. So, my period is pi over 4. Our original answer was pi over 12 and 4 pi over 12, which is pi over 3. Whatever, let's just keep adding pi over 4s. Yeah. So if we just keep going from here, sorry, yeah, tangent is weird sometimes. Tangent is really weird sometimes. We already have this one. So we should cross off all these guys essentially. And just say that our next one is going to be 10 pi over 12 plus 3 pi over 12, which is 13 pi over 12. And the next one's going to be that plus 3 pi over 12, which is 16 pi over 12. And the next one's going to be 19 pi over 12. And the last one's going to be 22 pi over 12. And if you did it one more time, you added another 3 pi over 12, you get 25 pi over 12, which is too big. So here's our answers. I'm sorry that got a little bit wonky there. I apologize. Yeah, so tangent's kind of funny in that instead of finding, you can find both answers and add your period to them, but yeah, I guess it just kind of, yeah, tangent's weird. Sorry, I know I keep saying that, but like tangent's just like is super kind of funky because you're getting, right, if you're going from 0 to 2 pi, you're getting the whole reading 8 periods. So really, yeah, the better way to think about tangent is find your one answer and then just add the period on 2 times 4 times. Ugh, gross. We might need to do another one here. All right, yeah, let's do another tangent one before we get into this one here. So extra tangent one. I feel like that one didn't go great. Let's try solving. Let's see, that was tangent, right? So let's try tangent of 3x equal to, let's try, we don't really have a whole lot of choices here. Let's try 1 over root 3. And let's make it negative. Okay, so same idea. We're thinking tangent of theta equal to -1 over root 3, or if you prefer, negative root 3 over 3. We know that we want angles in the second and fourth quadrant. I really should just stick to the second, but I'll still probably mention the fourth. So you're looking right. Not here, not here, here, and here. We know that we want a reference angle of, well, if we're looking for a 1 over root 3, we want the angle to be pi over 6. So our reference angle for this is theta equal to pi over 6. The angle that we're looking for in quadrant 2 is 5 pi over 6 because it's literally pi minus pi over 6. And quadrant 4, it's going to be, well, it'd be 11 pi over 6. Pi over 6. And our actual angle is going to be 2 pi minus pi over 6, which is 11 pi over 6. Cool. So, just want to make sure I say this the right way. So if we want to solve for x, here we're going to set 3x equal to the angle that we actually need. And then divide both sides by 3. So x is going to equal 1/3 times 5 pi over 6, which is 5 pi over 18. Now let me just think about this for a moment. Yeah. So we really don't need to do it over here. We could, but we're going to capture that by just adding on our period enough times. So let me show you what I mean. So the period of this tangent of 3x, so for y equal to tangent of 3x, the period is equal to pi divided by 3. If I change that to something over 18 and multiply that by 6 over 6, it's going to equal 18. Sorry, is going to equal 6 pi over 18. Sorry about that. So my first answer here is 5 pi over 18. My second answer is 5 pi over 18 plus a whole period, which is going to give me 11 pi over 18. Which is exactly what I would have gotten if I'd set 3x equal to this, right? 3x equal to 11 pi over 6, dividing both sides by 3 gets you exactly 11 pi over 18. So you really only need to find one and then keep adding on the period. So let's find the other 4 answers because there should be 6 answers total because there's usually 2 answers, but then we triple it because of the 3. I'm going to show you on Desmos as well because I think it's worth seeing. It's a little hard for me to graph. Hard for me to graph well. So 11 pi over 18 plus 6 pi over 18, 17 pi over 18. And then if we add another 6 pi over 18, or we're just adding 6 pi over 18 each time, we're going to get 23 pi over 18 because 17 plus 6 is 23. And then our next one is going to be 23 plus 6 is 29 pi over 18. And our last one is going to be 29 plus 6 is 35 pi over 18. And We're just under the wire there because 36 pi over 18 is the same as 2 pi. So these are our 6 answers. Now, let me show you what I mean by how this is working on Desmos. So let me just grab Desmos real quick because I do think this is worthwhile. Sorry, one moment, please. And fast forward this part. So share. Do it. So Desmos here. And if we graph, so I'm going to graph tangent of 3x. Tangent of 3x, sorry. And then I'm going to graph the y value that I want to equal to, which is negative 1 over root 3. Y equal to negative 1 divided by the square root of 3. So if we look here, we zoom in a bit between 0 and, let's see, 2 pi is a little bit more than 6. So let's see. But there's an answer. Oh, look, 5 pi over 18, 11 pi over 18, 17 pi over 18, 23 pi over 18, 29 pi over 18, and 35 pi over 18. And each of those answers is exactly 1 period apart, which is exactly 6 pi over 18 or pi over 3. And we zoom back out, you can be like, oh yeah, there's all those answers. Each of them 1 period apart. And those are all the answers between 0 and 2 pi. So in fact, if we break this off, right, if we limit ourselves to being between 2 pi, you can see we exactly get 1, 2, 3, 4, 5, 6 full periods of tangents. So we should get 6 full answers. And there they are. Sorry, kind of goes here. 1, 2, 3, 4, 5, 6. So kind of a cool way of visualizing it. Again, you don't need to graph it though to be able to do this. Let's go back to sharing the visualizer. All right, continuing on. So tangent's a little bit weird. You find one answer for tangent typically, and then keep adding on the period. Although it's not wrong to find both answers. It gets a little confusing, I think. Let's look at a few more examples. As an extra tangent example. Oh, here's another tangent example just hiding. Sorry, I knew better. I just didn't know I knew better. So to solve this one, you would start off by first saying, let's divide both sides by cosine of 2x. The sine of 2x divided by cosine of 2x equals cosine of 2x divided by cosine of 2x. And you can actually divide by either thing, but I prefer to have sine over cosine because I like tangent of 2x better than I like cotangent. You could do dividing by sine and cotangent of 2x. So same idea here. We want tangent of 2x to equal 1. Well, we know that tangent of pi over 4 is equal to 1, right? Like again, we're little triangle here. Tangent of pi over 4 is 1 over 1. It's also true in quadrant 3 that tangent of 5 pi over 4. So these are the angles I want. So I'm going to set my angle 2x equal to the angle I want it to be equal to, pi over 4. 2x equals pi over 4, divide both sides by 2, or multiply both sides by 1/2, so x equals 1/2 times pi over 4, which is pi over 8. And then find the rest of the answers. We take our period for tangent of 2x is pi divided by 2, right? Not 2 pi divided by 2, pi divided by 2. So take that period and add it on to pi over 8 until you get too big. So my x1 is pi over 8. My x2 is pi over 8 plus pi over 2, which is 4 pi over 8. Right? I'm just doing the, and that is equal to pi over 2. Then I can add them and get 5 pi over 8. And then if I do it again, 5 pi over 8 plus another 4 pi over 8. 9 pi over 8. And finally, 9 pi over 8 plus another period of 4 pi over 8 is 13 pi over 8. And if I went one more, it'd be too big. 13 pi over 8 plus 4 pi over 8 is 17 pi over 8, and that's bigger than 16 pi over 8, which is equal to 2 pi. So I do like thinking about how the fact that there's two answers to the original question, and then I'm multiplying by 2 to get 4 answers total. Yeah. Yeah, tangent's weird. I know I've said this like 5 times. Tangent is weird. Tangent's a little weird. Okay, a couple more. Ooh, cosine of 6x equals -1. So let's think about solving cosine of some angle equals -1. Well, -1's kind of special. Cosine equal to -1 only has one answer when the angle is pi. So we can expect to get, instead of one answer, 6 times 1 answers. So we're going to set 6x equal to our theta, which is pi, to get x equal to pi over 6. That's our first answer. Our period here is 2 pi divided by 6. There's no good reason to reduce that to pi over 3, because I know that my first answer is pi over 6. I want to add this to my first answer to get my next answer. So my first answer is pi over 6. My second answer is pi over 6 plus 2 pi over 6, which I feel silly to write. That's 3 pi over 6. I am going to reduce that, though, because in my final answer, my answers should be reduced. My third answer is going to be my previous answer plus another period of 2 pi over 6, right? Periods, which is 5 pi over 6. My fourth answer is going to be 5 pi over 6 plus another period. A little bit tedious. My fifth answer is going to be 7 pi over 6 plus another 2 pi over 6. Right? Just keep adding the period on. I should reduce that to 3 pi over 2. And then finally, my last answer, my sixth answer, is going to be the previous answer, 9 pi over 6 plus another period of 2 pi over 6, or 11 pi over 6. And these are my 6 answers. Pi over 6, pi over 2, 5 pi over 6, 7 pi over 6, 3 pi over 2, 11 pi over 6. Yes, so it is important to reduce your answers when you enter them into Canvas. But as far as doing this work here, it's actually better to leave this unreduced so that it's easy to add on 2 pi over 6 to get the next answer. I think this might be the last one. Yeah. Cosecant of 5x equals to -2. Let me see one thing. Oh, it's fine. Okay. So I don't like dealing with cosecant and secant and cotangent. I would much rather think of this as the reciprocal 1 over sine of 5x equal to -2, or even better, sine of 5x equal to -1/2. I'm just taking the reciprocal of both sides, saying the reciprocal of this is equal to the reciprocal of this. But another path to get there, if you prefer, is to multiply both sides by sine of 5x and say 1 is equal to -2 times sine of 5x, and then divide both sides by -2 to get 1 divided by -2 equals sine of 5x, which leads us back to sine of 5x equal to -1/2. To me, that's just easier to think about. So then I'm going to think about, well, if I have sine of theta equal to -1/2, well, I want sine of my angle to be the opposite of the hypotenuse, and my angle should be pi over 6. So I know that sine of pi over 6 is +1/2. So my reference angle is pi over 6. The actual angles are going to be in quadrants 3 and 4. So in quadrant 3, the angle is going to be 7 pi over 6. It's pi plus a pi over 6. And in quadrant 4, it's going to be 2 pi minus pi over 6, which is 11 pi over 6. So those are my two beginning angles. So I know that I want theta equal this and that, but my theta is really 5x. So I should really be saying that I want sine of 5x equal -1/2. So I need either 5x to equal 7 pi over 6 or 5x to equal 11 pi over 6. So starting with the 7 pi over 6, 5x equal to 7 pi over 6 is going to lead to x equal to 1/5 times 7 pi over 6, which is going to be gross. It's going to be 7 pi over 30. In a similar way, this one here is going to lead us to x equal to 11 pi over 30. And the period here is 2 pi divided by 5. So for sine of 5x or cosecant of 5x, they both have the same period. Period is 2 pi divided by 5. I'm going to get a common denominator, multiply by 6 over 6. That's going to be 12 pi over 5. Okay, so we're going to take this answer here, x1 equal to 7 pi over 30. And we're going to add on 12 pi over 30. Sorry, I wrote the wrong thing there. So 7 plus 12 is 19 pi. And 19 plus 12 is 31 pi over 30. And 31 plus 12 is 43 pi over 30. And 43 plus 12 is 55 pi over 30. And that's as many as I should get from that one. And then my next one over here was 11 pi over 30. And then again, I'm going to add my period, 12 pi over 30. 11 plus 12 is 23 pi over 30. 23 plus 12 is 35. 43 plus 12 is, sorry, 35 plus 12 is 47 pi over 30. And finally, 47 plus 12 is 59 pi over 30. Just shy of 60 pi over 30, which would be 2 pi. So there's my 10 answers. I didn't really need the x1 here. I will point out that a few of these do reduce. Specifically, 55 pi over 30 reduces to 11 pi over 6. And 35 pi over 30 reduces to, if we divide the top by 5, 7 pi over 6. It's kind of coincidental that those happen to be the original answers before dividing by 5. Sometimes weird things happen with numbers. So these are our 5 answers. And in order, right, it's 7 pi over 30, then 11 pi over 30, then 19 pi over 30, then 23 pi over 30, then 31 pi over 30, then 7 pi over 6, then 43 pi over 30, then 47 pi over 30, then 11 pi over 6, then 10 pi over 30. All right, so solving these can be a little bit tedious, but the process is pretty much the same every time. You find the angles first, in this case, 7 pi over 6, 11 pi over 6. You divide them by whatever the coefficient of x is, in this case 5, to get 11 pi over 30, and sorry, to get 7 pi over 30, 11 pi over 30, and then you add on your period, in this case 2 pi over 5, as many times as you need to. In this case, we need to get 10 answers total, so we need to do it 1, 2, 3, 4, 5 times for this one, and 1, 2, 3, 4, 5 times for that one. And those are your 10 answers. All right, hopefully that wasn't too bad, and I will see you all later.